Solar System. Think Different Version 1.
When we first heard about the solar system, we thought it looked like a huge atomic structure. The Earth we live on is a member of the solar system, like an electron in an atom. The Sun is at the center, like the nucleus of an atom, and the Earth and other planets revolve around the Sun, just like electrons moving around the nucleus. But comparing the two, there is a big difference. Regarding the atomic structure, although no one has ever experimentally measured the specific movement of electrons around the atomic nucleus, the electron trajectory given by the solution to Schrödinger's equation is still cited by everyone without raising any objection. That is, electrons move in all directions around the nucleus. However, the motion trajectories of all planets in the solar system around the Sun are almost parallel, or on the same plane. In addition, although the motion of each planet around the Sun may be faster or slower, it is all in the same direction.
Video of the planet movements in solar system.
Why does the Earth spin and orbit the Sun at the same time? When Newton discovered the gravity of the Earth, he was also puzzled by this question. At the time, he could not give an explain, so he said mockingly, "God kicked it."
However, today people have been into the space. The Hubble telescope has sent back a large number of photos of nebulae and planets. Many nebulae show the shape of a vortex in the photo, indicating that they are rotating around a center, or are forming a center of rotation. Therefore, spin is a common property of all celestial bodies. In the third photo, the nebula appears like a cigar. Maybe the photo was taken from a side angle of the nebula. Why do celestial bodies rotate in space? We've all seen firecrackers being lit. Once ignited and the reaction occurs, the firecracker will violently eject gas outwards, and itself will be pushed to a side due to the reaction force. Immediately next burst of gas will push it to another side. The continuous bursts of gas push the firecracker in different directions all the time, eventually forcing it to spin around a center. Nebulae in space are like lit firecrackers. The internal nuclear reactions cause them to erupt reaction particles in all directions. Finally, nebulae start to spin around a center like firecrackers. But, why do lit firecrackers not form a rotating ball, but a rotating disk? Because they are on the Earth, under the influence of gravitational field. The solar system is also under the influence of Milky Way force field. Therefore it also only forms a rotating disk instead of a sphere. Naturally, we can make the assumption that the entire solar system, the Sun and the planets around it, is originally a nebula, the solar nebula. Due to the nebula's nuclear fusion reactions, it periodically ejects large amounts of particles and atoms. When particles and atoms leave the solar nebula, they continue to rotate around the nebula center due to inertia. This is their orbital circulation. The ejected fiery particle clusters initially continue their nuclear reactions. So in addition to the orbital circulation, they also started to rotate around their own center, that is spin. As time passes, the ongoing nuclear reactions eventually ceased, the temperature gradually fell down. The particle and atom clusters gradually formed stable molecules, coalesced together, and finally formed planets. Two facts may serve as basis for this hypothesis. 1. The orbits of all the planets in the solar system are almost in the same plane, and the planets revolve around the Sun in the same direction. Therefore, they are most likely formed by the nuclear reaction eruptions of the solar nebula. The erupted material originally belonged to the solar nebula, and the planets formed by their agglomeration will continue to rotate around the center of the Sun. Not only the rotation directions are consistent, but the rotation orbits are parallel, close to be in one plane. 2. The planets in the outer reaches of the solar system, Neptune, Uranus, Saturn and Jupiter, are composed of the primary reaction products of the nuclear fusion in the solar nebula. At that time, the atoms and particles produced by the reaction were smaller and lighter. After cooling and condensed, they formed some molecules of light atoms, such as hydrogen, H2, oxygen, O2, nitrogen, N2, helium He, water, H2O, ammonium, NH3, etc. At low temperatures, these molecules form the icy cores of the outer solar system planets. Particles ejected by later nebula reactions formed the planets orbiting the inner solar system, Mars, Earth, Venus, and Mercury. The components of these planets are particle atoms ejected at a later stage of the nebula's nuclear fusion reaction, so they contain some heavier atoms, such as iron, Fe, sulfur, S, etc. These atoms can form stable oxides and sulfides molecules. They have high freezing points and form a hard shell on the surface of the planet after cooling. The shell keeps hot temperature at the planet core. The remaining fiery particles and atoms continue their nuclear fusion reactions. The solar nebula gradually shrank after a series of nuclear fusion eruptions. And the ejected particles and atoms have formed a series of planets from the nebula outside to the inside, thus forming the solar system. Here listed the data of all planets in the solar system on Wikipedia, the distance to the Sun, the period of one revolution around the Sun, and the period of the spin. The data in the above table shows that the outer planets of the solar system, Jupiter, Saturn, Uranus and Neptune, as they get farther away from the Sun, their revolution periods get longer. This is easy to understand. But on the other hand, these planets' spins are very fast, their spin periods are very short. This may because they were ejected from the solar nebula very early, their selves nuclear reactions happened longer, therefore their spin speeds become faster. If take the planet orbits around the Sun approximately as circles, and take pi as 3, use v equals 2 pi r/t to calculate each planet's linear orbit speed. R is the distance from the planet to the Sun. T is the planet's orbital period around the Sun, then the linear velocities of each planet on the orbit are obtained respectively. The calculation data shows that the farther away from the Sun, the slower of the planet orbital linear velocity. Perhaps these planets had been ejected from the nebula for a long time, their motion inertia gradually disappeared. In the fact, the outermost Pluto has already left the solar system. The two tables' data shows, solar system planets can be roughly divided into two groups. Jupiter, Saturn, Neptune and Uranus are the planets farther from the Sun, Mars, Earth, Venus and Mercury are the planets closer to the Sun. In each group the planets' data of their distances to the Sun and their orbit circling periods variant gradually and sequentially. However, between the two planets, Mars and Jupiter, the change of their distances to the Sun and their orbit circling periods show great jumps. Why is there such a sudden change? Maybe we can find the reason from the figure of solar system. There is an asteroid belt between Mars and Jupiter. As can be seen from the figure above, there is a big gap between Jupiter and Mars. There would be a position for a planet, but now instead of a planet, a meteor belt appears. Perhaps between the eruptions of Jupiter and Mars, the nuclear reaction in the solar nebula did not have one concentrated eruption, but in multiple eruptions. Therefore, instead of condensing into a giant planet, the erupted particles formed a meteor belt between Jupiter and Mars. This just proves again that planets are formed by ejected particles of nuclear reactions in the solar nebula. Thanks for watching, goodbye.